Today we are talking about dependent events. And we know that compound events can be both independent or dependent. We talked about independent yesterday. And today, dependent events, which are events where the outcome of the first event does affect the outcome of the second event. And the probabilities of such event we can find this way. Probability of both happening would be probability of the first event times the probability of the second event after what happened with the first. So let's look at this. This will be much easier when we see the examples. So we have 7 green, 4 blue, and 3 red marbles in a bag. We draw 1 marble from the bag. We do not put it back before we draw the second marble. So we do not replace it, and then we draw another marble. Let's see, what is the probability that both marbles are green? So the probability that the first marble green is 7 greens out of 14 total. Now, when we draw the first marble and we do not put it back, we actually have 1 less marble in a bag total, and we have 1 less green marble in a total. So from our bag, the probability that the second one will be green is 6 green left out of 3 marbles total. So to multiply those two probabilities, we can simplify 7/14 to 1/2, multiply by 6/13. We have 6/26, or simplify to 3/13. So it's kind of a close to 1/4 probability, or about 25% that both of them are green. Let's see the probability that first one is green and second one is red. So first green, second red. So for the first one, we have 7 green marbles out of 14 total, which can be simplified to 1/2. But because we did not put the first marble back after we pulled it out of the bag, we have 13 marbles left total. And how many of them are red? We still have 3 red. So that will be probability of second one being red is 3 out of 13. Multiply them out, we have 3/26. Now let's look at this example. Mr. Parietti needs 2 students to help him with a science demonstration for his class of 18 girls and 12 boys. He randomly chooses 1 student who comes to the front of the room. He then chooses a second student from those still seated. What is the probability that both students chosen are girls? So we want probability that first is girl and second is girl. Probability that the first one is girl is how many girls we have out of total number of students, which is 30. Now, when the first person comes out and it's a girl, we have 29 students left seated, and out of those 29, we have 17 girls there. So the probability that the second one is girl will be 17 out of 29. And then to simplify this as much as possible, 18/30, it can be simplified to 3/5. Multiply by 17/29, we end up with 51 1/45, which when you look at it, it's about 1/3, so about 33% chance that both of them are girls.